Over the past 10 years, production of single-engine aircraft, the foundation of all flight, has declined dramatically in this country. One of the most damaging effects of the slowdown is that most small production planes in use today still feature 1930s or 40s technologies. NASA, the FAA, and more than 60 U.S. companies are currently forming a partnership to reverse this trend. One of its primary goals is to stimulate demand for new aircraft by making them less complicated and expensive to fly. Advanced cockpit systems. Cost-effective ways of manufacturing with composite materials. Crash-worthy airframes. Alternative passenger restraint systems. And quieter propellers are just a few of the program's targets. The hope is that implementation of technologies like this will bring personal flying to a new level. NASA Program Manager Bruce Holmes.
Imagine what your life would be like if you could fly at 10 or 20,000 feet over the gridlocked interstates down below at 250 miles an hour with 4 or 6 people on board at 30 miles per gallon in an airplane that costs the same per mile as the airlines and maybe not much more than a car.
General aviation refers to a wide range of aircraft, from small trainers to high-performance business jets, medevac helicopters, and crop dusters. There are currently more than 200,000 servicing landing facilities nationwide. In many rural communities, these airports are the 20th century equivalents of the river ports and railheads of the past, providing access to the mainstream of business and commerce. But over the last 10 years, production of single-engine planes, the foundation of all flight, has declined dramatically in this country. Ed Stimson is president of the General Aviation Manufacturers Association.
General aviation is where it all begins. Most of the pilots in the United States learn to fly in a general aviation aircraft. Unfortunately, in the last few years, we've had some tough times, but we're coming back.
One of the reasons for this optimism is that NASA, the FAA, and more than 60 U.S. companies are forming a partnership to breathe new life into the industry. NASA Program Manager Bruce Holmes.
Our program in its early years is operating in a save-the-patient mode. If you look at general aviation like you would look at a patient in the hospital, its vital signs are all declining. You know, the number of airports, the number of pilots, the number of airplanes, all of those are declining at a precipitous rate. And so we're in a save-the-patient way of thinking.
One of the problems being addressed is that most light production planes still feature 1930s or 40s technologies. Paul Fiducia heads up the Small Aircraft Manufacturers Association.
What we need to do is incorporate new technologies that are currently available and need to be integrated into the aircraft at an affordable cost that will make it possible for a vastly larger segment of the population to learn how to use an airplane safely and reliably for almost all weather operations in a reasonable amount of time.
A principal target of the NASA FAA industry program is the small plane cockpit. Becoming an all-weather pilot today requires mastering a variety of control systems and instruments, a very time-consuming, costly process. In the NASA-developed advanced cockpit concept, all this information is reorganized on touch-sensitive flat-panel displays. The front windshield provides a highway in the sky to fly along. Timely weather maps for rerouting around storms can be brought up through data links. Global positioning satellites, or GPS, are used to depict the precise locations of other aircraft in the area and safely avoid them. Other systems help eliminate potentially dangerous mistakes, like not having enough fuel to complete the flight plan. Taken as a whole, these new cockpit technologies could cut the cost of obtaining and maintaining all-weather flying skills in half. The first steps towards advanced cockpits are already being taken. Multi-purpose displays and GPS navigation devices have been added to some of the existing fleet. They're also becoming widespread in what's referred to as the kit-built segment of the industry. Kit-built means exactly that. A buyer purchases a kit containing all the necessary pieces, then does most of the assembly work. Some of the fastest, most innovative small planes come from kit manufacturers. One of the keys to achieving this kind of performance is that nearly all are made of composites like fiberglass or graphite that are just as strong, but much lighter than traditional metals. The drawback is that working with composites can be a very labor-intensive, costly process. As part of its partnership with industry and the FAA, NASA has already begun identifying more efficient ways of utilizing these materials. The goal is to reduce the expense of manufacturing composite airframes 25 to 40%. Information about strength and durability is also being gathered at NASA facilities, both on a small as well as a much larger scale. Crash tests like this at NASA's Langley Research Center will help develop key databases and design guidelines. They are also being used to determine whether new restraint systems or even airbags might be added to improve safety. Research aimed at low-cost, non-destructive inspection techniques and icing protection systems is also underway. Electronic controls developed for jet engines are being adapted for the piston power plants that drive most small planes. Even the propeller is getting a serious second look as engineers seek more efficient, less noisy designs that will help make future general aviation aircraft as quiet and comfortable as today's automobile. Once in place, the variety of technologies being targeted should bring personal flying to a new level. Again, NASA's Bruce Holmes.
Imagine what your life would be like if you could fly at 10 or 20,000 feet over the gridlocked interstates down below at 250 miles an hour with 4 or 6 people on board at 30 miles per gallon in an airplane that costs the same per mile as the airlines and maybe not much more than a car.
Cessna, who used to be the world leader, producing 9,000 single-engine airplanes a year, has not produced a single-engine airplane since 1986.
We believe that general aviation can play a much more significant role than it ever has in the transportation system by opening it up to many more people who currently are deterred from flying because of the cost of obtaining and maintaining proficiency and the cost of operating the aircraft.
One of the hallmarks of this program will be speed of product to the marketplace from the program. Our timeline for the nearest term impact in the marketplace is 18 to 36 months. This program is a cost-sharing program. Half the resources come from the government, half the resources come from industry.